Assalamualaikum and selamat sejahtera. Hello, my name is Mohamad Daniel bin Sluhudin Hamdan. My ID metric is B0319110495. Me and my group will be presenting about brute force bubble sort. What is bubble sort? Bubble sort is one of the simple yes sorting algorithm. It is also called as an exchange sort. This sorting algorithm is a comparison-based algorithm in which each pair of adjacent elements is compared and the elements are swapped if they are not in order, which means that it will continue to visit the array until no swap are needed and the array are in sorted order. This algorithm is not suitable for large data sets because its average and the worst case complexity are 0 and square, which are n are number of items. How bubble sorts works. So we take a simple unsorted array for example. Bubble sort start with the first two elements and comparing them to check which one is greater, and then if they are not in sorted order, it will exchange the place. For this one is 5 and 1. 5 is greater than 1, so it will change the place, so it will swap. As you can see there, it will swap the place and then move on to the next element, which are 5 and 4. 5 is greater than 4, so they will change place again. Next, we check the next element, which are 5 and 2. 5 is greater than 2, so they will change place again. Now we move on to the next value. 5 is less than 8, so it's already in a sorted location, as you can see here. So it will not change, no swap are needed. And then move on to the next value. 8 is less than 9, so it is already in sorted location. At the end of the sort, it will look like this, but we know that 4 is not supposed to be here and 4 is larger than 2, so it's still not in the sorted order. Then we move on to the sorting the second time. The first sort, same exactly as in the first example. Take the first two elements and then compare them to each, and then swap them if they are needed to swap. 1 is less than 4, so it will not change place. The second sort, 2, 4 is not less than 2, so it will change the place. It will keep swap checking, compare and swap if they are needed until the end of the sort. It will in the sorted order.
Hello and Assalamualaikum. My name is Ahmad Hazim bin Ahmad Rizal, and I will be explaining the real-life implementation of the bubble sort algorithm. The bubble sort algorithm doesn't just apply to the virtual world but also in the real world. In fact, its origin, or should I say its concept, is of course from the real world. So now let us take a look at an example of the bubble sort in the real world. There are two examples of scenario that we are able to come up with, which are cars driving at different speeds and students queuing up. Let's start with cars driving at different speeds. Suppose there are 4 different cars on a road, each driving at a different speed. By default, the car with the fastest speed will overtake cars that are slower and eventually ends up being in front of the slower cars. The process repeats for the other cars until eventually the fastest car ends up being at the front and the slowest car ends up at the back. As a result, the 4 cars are sorted in ascending order according to their respective speed. Seems logical enough, right? Let's move on to the second example. Another example is when students are queuing up in a straight line and the order must be from the shortest to the tallest. Imagine this. As a prefect, you are required to sort the students before the assembly starts. Using the bubble sort algorithm, you are able to sort them in ascending order by comparing each of their heights and determining when it is true to swap the two of them. If the statement I is taller than J proves to be true, then you may swap the two students' positions. If the statement I is taller than J proves to be false, do not swap their positions and move on. This process of swapping is repeated until eventually the tallest ends up at the back and the shortest in the front, so that the shortest student can see the principal giving a speech on stage and have no one to obstruct his vision. As a result, the queue will look like this, perfectly sorted from the shortest to the tallest. So there you have it, two examples of real-life implementation of the bubble sort algorithm. And I hope you understand its concept through these two examples. Now, we move on to the next explanation.
Hello there, my name is Adhwa Danish bin Mohamad Noor. My metric number is B0319104661. I will be presenting about the code of bubble sort. The main objective for bubble sort is to move the largest item inside the array to the back or to the end of the array. Next, bubble sort algorithm will compare the current item and the next item, or you could say they compare from index and index plus 1. There is another thing in bubble sort. We call it as pass, but that part I will explain later after explaining the bubble sort algorithm codes. So here are my codes. I already typed it before presenting. So first of all, the program will ask the user to input the number of the array size, and then I declare the array and the array size I and j also to increment the number of index, and then the program will ask the user to input the items inside the array. So here is the for loop, and this is the nested loop, and this is the if statement for the swap command. As you already know, bubble sort will compare the first item, the current item, and the next current item next to the current item, which is, this is why I put array j and j plus 1. Okay. Then the array j will be put inside temp, which is the variable I use for temporary placement, and the j plus 1 will replace the item inside array j. Array j plus 1 will also be overwritten by the temp. And this is the for loop to just display the array after being sorted. To show you how it works, I will use this program. Let's just say I will put the array size to 5. Enter numbers inside the array. Let's say it's 15, 5, 23, 2, and 17. Okay, so this is the sorted array. So to show how this works, I will be using Notepad to show you how it works. So this is the unsorted array before running the bubble sort algorithm codes. To show you how it works, the first thing, it will loop. It will compare the array j and array j plus 1. And this is why, if j is equal to 0, let's put here j is equal to 0. So j equal to 0. J equal to 0 is placed on array number 1, placement number 1, which is 15. And j plus 1 will be 5. And it will compare 15 to 5. 15 is indeed bigger than 5. So it will swap 5, 15, 23, 2, and 17. The main objective of bubble sort will put the largest number inside the array to the back end of the array. So after this happens, it will loop and increment the j plus plus. So j plus plus it will be j equal to 1 now. J equal to 1 is placement number 2 inside an array. So 5, 15, instead of putting 15 here, we'll have to compare 15 and 23. 15 is less than 23. So what will the program do? The program will skip this swap command. It will not swap the number 23 and 15 because 15 is less than 23. So maintain the same, 2 and 17. So right now we will increment the j again, j equal to 2. When j is equal to 2, in the number of array, it will be placement number 3. So right now, what happens is, this is called as the 1 pass. This is the first pass. The first pass is achieved when the largest item inside an array is already at the end of the array. So what will it do? It will exit the nested for loop. It will go to the outer for loop, the main for loop. So instead of I equal to 0, it will be I equal to 1. If you notice, I didn't use I right now. I used J. Why I use J and why I use I? It is because when I loop, I put n minus I minus 1. Why n minus I? Because every time we loop, every time we exited the nested for loop, we will have to increment I, which is just now I is equal to 0. That is why I didn't minus I from n. So the number of loop will be lessened by this. And then we will go to the next loop. The next loop, I will equal to 1. So n is less than 5 because n is minus by 1, which is 4. So right now, we don't need to have j until 4, which is placement number 5. We will have until 3 only. Let's see how it works. So for the first one, of course we still use j. J is equal to 0. But first we will have to compare 5 and 15. 5 is less than 15, so we don't need to swap the numbers here. This is j equal to 0, which is placement number 1. And then j is plus plus, j incremented, j is equal to 1 right now. And j equal to 1, j plus 1 will equal to 2. So we will have to compare 15 and 2. 15 is indeed larger than 2. So we do it like this. So 15, 17, 23. This is j equal to 1. And then we will have to compare, because of j is incremented again, j is equal to 2 right now. When j is equal to 2, 15 will be compared to 17. But right now, 17 is larger than 15, so leave it be. 5 to 15, 17, and 23. This is j equal to 2. And right now, this is where the command of n minus 1, I, n minus 1 is implemented, because 17 is indeed the number 3 in the j array, placement number 4, but the index is number 3. We don't need to compare to the largest number, because in every pass I incremented the I to make sure that we don't need to compare the largest number, which is at the end of the array, to the smaller number. So whenever the 1 pass is achieved, or second pass is achieved, The incremented number of I will help decrease the number of loops needed to identify the array. So right now, when 17 compared to 23, it is indeed that 23 is larger. So that is why I skip this by using this code. So this is the second pass. And the third pass is when 5 is bigger than 2, so swap the command 15, 17, and 23. This is j equal to, this is j equal to 0, and then 5 needs to compare with 15 first. Right now we don't need to compare the number second of the index and the third of the index, just 5 and 15. But 5 is already less than 15, so we don't need to swap it. So when we increment it to number 2. So when we increment it to number 2, which is right now on, my bad, number 1, we need to compare 5 and 15 only. 15 is indeed larger than 5, so leave it be. And right now, we don't need to compare to 17, because 17 is of course larger than 15. And it is already on second pass. Second pass means I equal to 2. And when n minus 1 and minus I, which is I is equal to 2, which is 3, 5 minus 3 is 2. So the loops needed on j is just 2 to identify the largest number inside the array. So there you have it, 2, 5, 15, 17, and 23 here.
Hi and Assalamualaikum. My name is Ahmad Nabil bin Zulkifli. I am from the ITS S1G1. My metric number is B0319100066. Today I would like to share about an algorithm that is better than bubble sort, which is merge sort. What is bubble sort? Bubble sort works by passing values from left to right. Basically, if we are doing ascending order of sorts, the larger value will bubble towards the end. If the value is already in order, it will leave them, while it will swap the value that is not in order to the right. And then it will repeat this until there's no value to swap. Bubble sort is an easy and simple algorithm, but it will loses its effectiveness as the value to be sorted grow. So we need to adapt a better approach for sorting. Now we are going to see a more useful algorithm, which is merge sort. What is merge sort? Merge sort is one of the fastest method to sort a data, especially for a large data set. Merge sort is a divide and conquer algorithm. Divide means that the algorithm is divided into two halves, which is first and second, with similar size. Then the conquer part is the part where both parts of sublist are sorted recursively. Recursively is meant by calling the algorithm within the algorithm. Then after the both part of sublists are sorted, we can combine them by merging both sorted sublists into one sorted list. Now we will see how merge sort works. So we're going to have the input like right here, and we will end up with the output like right here. The first step is to divide this input into two sublists of equal size. Then this is where recursion comes, where the algorithm is calling for itself, and we will divide it again like this. This will happen until each sublist size is equal to 1. So now we have done the divide step because each of the sublist size are 1. Now we're going to conquer them. To conquer, we have to sort them. So we try to sort 3 and 5. 3 and 5 are already sorted, so we just combine them. 2 and 6 are already sorted, so we just combine them. And 7 and 4 are not sorted, so we have to swap their place. Now we want to combine these two. What it will do is it will look at two smallest elements in sublist and compare them. So 3 and 2. 2 is smaller than 3, so 2 go first. Then 3 and 6. 3 is smaller than 6, so 3 go first. Then we compare 5 and 6. 5 is smaller than 6, so 5 go first, and then 6 will come in. Later, we will combine these two input in order to get our output. These two sublists in order to get our output. We compare the smaller number of each sublist. So we compare 2 and 4. 2 is smaller than 4, so 2 go first. Then we compare 3 and 4. 3 is smaller than 4, so 3 go first. Then we compare 5 and 4. 4 is smaller than 5, so 4 will go first. Then we compare 5 and 7. 5 is smaller than 7, so 5 go first. Then we compare 6 and 7. 6 is smaller than 7, so 6 go first, and then 7 will come in. Now let's compare which one is better between bubble sort and merge sort. Bubble sort uses an iterative approach where it will loop through elements to sort, while merge sort uses divide and conquer approach. The time complexity for worst case for bubble sort is n squared, while for merge sort is n log n. Time complexity for average case for bubble sort is n squared, which is pretty bad, and merge sort is n log n. For large data set, bubble sort is not efficient, while merge sort is consistently efficient. Now, let's say that we have 1000 input. For merge sort, we only need about 3000 units of time over memory. You can get it by type in your calculator, where is 1000 log 1000 is equal to 3000. But for bubble sort, if we have 1000 units of input, we will need over 1 million units of time over memory, because of the time complexity for average case is n squared. 1000 square is 1 million. So that's pretty bad. So to conclude this, merge sort is definitely more effective than bubble sort algorithm in terms of time, and it is a better algorithm as our main concerns always through the large data sets. That's all from me. Thank you.